Hi everyone, this is week 12 session of Physico Chemical Processes for Wastewater Treatment. So this is the online session for Physico Chemical Processes for Wastewater Treatment. This is week 12 lecture, and this course is offered by Professor V.C. Srivastav from IIT Roorkee, uh, and I am the TA for this course. I am Vaibhav Kabadwal, a PhD scholar at IIT Madras Civil Engineering Department. My specialization is environmental engineering. This is the lecture outline. In this lecture, we will study industrial wastewater treatment, CETP, and choice of technology. So now we will start with industrial wastewater treatment. The quantity of molasses averages about dash percentage of the cane crust. So the answer is 5%. As per CPCB guidelines, for all the sugar industries in India, the wastewater generation shall not exceed how much meter cube per ton of the cane crust. It's already specified here, 0.1 to 0 cubic meter. The overall pH of the wastewater generated from spent lees in the distillery is the overall pH of the wastewater generated from the spent lees. So spent lees is an oily, cloudy liquid with a slightly oily aroma. So the pH is very less, around 3.6 to 4.5. Indian fermentation industry categorized as maltery, brewery, and distillery based on either dash or grain, which is based on either molasses or grain. The brewing process requires a significant amount of water and the produces wastewater is high in dash and suspended solid content. So the question is asking the brewing process requires a significant amount of water and produces wastewater which is high in BOD. The brewing industry produces wastewater which is high in BOD and suspended solids. Electrochemical denitrification could not be used to remove ammoniacal nitrogen from wastewater. Actually, this electrochemical nitrification plus denitrification can remove ammoniacal nitrogen, can remove ammonia. But here so the answer is false. The major use of water in petroleum refining is for steam generation and heat transfer. True. So the major use of water in petroleum refining is for steam generation and heat transfer. It is correct. What is the limitation of free ammoniacal nitrogen according to the effluent discharge standards for straight nitrogenous fertilizers prescribed under Environment Protection Rule 1986? So what are the limitations? This is 4 milligram per liter. ZLD stands for in the wastewater treatment as so ZLD means zero liquid discharge. Zero liquid discharge. Which treatment option is most suitable for low TDS, high BOD, and low difference between COD and BOD? So if the difference is less between COD and BOD, we'll go for biological treatment. and TDS is also less. So we will go for anaerobic with aerobic treatment. Which process is for secondary treatment comes under the following? Which process is for secondary treatment comes under the following? The sedimentation process generally comes under primary process. This will come under preliminary process. So the process which comes under secondary treatment is mostly activity sludge process. Electrochemical may either come under tertiary process. So the answer is activated sludge process. Which water treatment is generally used in households for drinking water purpose? For drinking water purposes. Which water treatment is generally used in household for drinking water purpose? So sedimentation is not used in household, not in homes. Activated sludge is also not used in homes. Ion exchange can be used in homes, but it is not used because we have to change the bed every time and change the media for ion exchange. But reverse osmosis is mostly used in the households. You might have heard like RO plus UV system, RO plus UV, like that. So RO is to remove, reverse osmosis process is used to remove the uh, solids dissolved and suspended, and UV is to disinfect the bacteria, disinfect the microbes, disease causing microbes. So answer is reverse osmosis. What are process and non-process based water usage in molasses based distillery? What are the process and non-process? See, what are the process and non-process based water usage? So there are two types of water usage. One is process based, one is non-process based. Non-process based water usage. I would write water usage. It can be process based and non-process based. So what are these? So process based application, yeast propagation. For yeast propagation means the process of increasing the population of yeast cells. So this is process based application. So we need water for yeast propagation, preparation of molasses for fermentation, and water as a steam required for distillation. So for these three processes, we need water. For non-process applications like these are not process-based applications. These are non-process applications like cooling water, treated water for making potable liquor and for boiler use, and water and steam required for washing. Wastewater generated from the beer manufacturing amounts to dash of the water intake volume. Water generated from beer manufacturing amounts to dash percentage of water intake volume. So so they're asking if you're using 100 liter. So out of 100 liter, wastewater generated will be 65 to 70 liters. So around 65 to 75% of the wastewater is being generated from the beer manufacturing. What are the following options that can be adopted for the treatment of effluent from distillery units as per MOFCC guidelines? So the following options which can be adopted are anaerobic digestion, anaerobic digestion followed by evaporation and composting if the distillery unit is attached to the sugar unit. And second is concentration and burning in the boiler for standard distilleries. What are the technologies available for the removal of ammonical nitrogen? So what are the technology for removal of ammonical nitrogen, NH3 or NH4 plus? So these are air stripping. So in this, what we do, we increase the pH and strip ammonia. Ion exchange, we exchange ion simply. Reverse osmosis, it will uh, we'll use the membrane, and that membrane will not allow the ammonia molecule to pass. Chlorination means we apply the chlorine, and at break point chlorine, we will get uh, the ammonia will be removed. Biological nitrification and denitrification. So this we can go in biological systems. Electrochemical nitrification and denitrification. So in this, nitrification of ammonia at anode and denitrification at cathode occurs. So due to oxidation and reduction, the ammonia can be removed. Name some primary nutrients. So these are nitrogen, phosphorus, and potassium. These are the primary nutrients. Based on nutrients present in fertilizers, they are categorized as straight fertilizers and complex fertilizers. So straight fertilizers are they will contain only single nutrient. Example urea and ammonium salts. Like if we say urea, the formula is CONH2 whole twice. So it will contain only one uh, nutrient, that is nitrogen. But if we see the complex fertilizer, it consists of more than one nutrient. So like example of diammonium phosphate. So it will contain nitrogen and phosphorus both. So complex fertilizers are those which consist more than one nutrient. Now we will talk about CETP. So what is the full form of CETP? See, the full form is Common Effluent Treatment Plant. So we are aware of this thing, effluent treatment plant. So for an industry, we use effluent treatment plant to treat the wastewater coming out of an industry. So when there are multiple industries and these are very small, that they cannot treat their wastewater, and if their wastewater is very less in quantity and they cannot afford to have a treatment unit, or they cannot afford to have uh, required treatment units, because they have to make some profit also. So uh, based on the energy perspective, and uh, the perspective are energy perspective, and second perspective is land area, land available or not, because for treatment units you need to have a land. So what we do, we provide uh, we provide the common effluent treatment plant so that it can the wastewater from different small industries is collected and then it is treated in a common effluent treatment plant. So which can reduce the cost of treatment. If we see the collectively, cost of treatment can be reduced, and land area the land area is not required by the individual industrial uh, the land area is not required by the by the individual industry. Land area not required. Land area not required by individual industry. By individual industry. So these are the benefits, and treatment can be done simultaneously. Treatment can be done simultaneously, and there are many more advantages, and there are little bit disadvantages also. So we will study further. Just to give the background, I gave an insight. What is full form of CETP? So CETP is Common Effluent Treatment Plant that we understood. Uh, And so what is CETP? Where cluster of industries are there, effluent collected from different industries for those primary treatment is done, which is further treated in the common effluent treatment plant. So like we discussed, so when cluster of industries are there, they will do some primary treatment to remove some pollutant which may affect the common effluent treatment plant. So we need to remove that pollutant, that is that peculiar pollutant we need to remove so that the rest of the wastewater which is sent to the CETP so that it can be treated easily without affecting the common effluent treatment plant. So that's why we provide some preliminary units at the industry itself. We can see it here. Suppose industry 1 is here, A, so it will treat something, primary treatment. Industry B is here, they will also treat some water. Industry C is also here, it will also treat some amount of water because these are different industry. So their wastewater will then be sent to a common effluent treatment plant, and then it is discharged. What is the concept of CETP facility? So small industries may generate a small quantity of wastewater that we discussed. Treatment may require land area, treatment facility, and energy cost. So which is taken care by CETP. So CETP will take care of all those things. And the number of discharge points can be reduced. So this is the concept of CETP. CETP. CETP are centralized or decentralized facility. CETPs are centralized facility. So, what are decentralized facility? In decentralized facilities, we distribute the resources, decision-making authority and operations across multiple locations or entities. So we distribute the resources, decision-making authority, and operation across multiple locations or entities. But while in centralized, all things are provided at one place and at one. So all the wastewater will be sent to one one place, and all the resources and decision-making authority at one location itself, not at different uh, places. What are the advantages of CETP? The advantages are facilitates economy of scale in wastewater treatment, thereby reducing the cost of pollution abatement for individual SME. So the cost is reduced, addresses the lack of space issues. So the cost reduces the space required by the individual industries. If we see the collective figure, we can realize that the space occupied by the individual industries is more. So that's why it reduces the space constraint also. You can reduce the space. CTP can be planned in advance. This can be planned in advance to ensure the adequate space is available, including plans for expansion in the future. Homogenization of wastewater. So a homogeneous wastewater can be produced as effluent from the CTP. Relatively better hydraulic stability, professional control over treatment can be affordable. So if multiple industries will treat their wastewater, it will be expensive. Uh, if you see the collectively, if you see like in the four industries are treating their wastewater in their own insight, in their insight or in-house, so it will be costly. But if we see the wastewater treated in CTP, uh, it will be at low cost, and it is affordable, so they have to pay the minimum amount for the treatment of their wastewater. Provides opportunity to improve the recycling and reuse possibilities. Facilitates better organization of treatment effluent and such disposal. So the water can be recycled and reused, and it can and for better organization, treated effluents and the disposal. So, if you see the small industries, so the sludge disposal, it will be a tedious job for individual industry. So it will be better organized if you provide a CETP. What are the problems and constraints with CETP? So the problems are consistency in compliance, consistency in compliance to the prescribed standards by CETP is constrained by many reasons, such as operating on one size fits all basis. So the thing is that there is an assumption uh, before designing a CETP. Like we will get this wastewater, this much amount of wastewater of this much. Even though we decide a range of wastewater characteristics, but it but sometimes it may fail because the wastewater characteristic range may go beyond the expected. So that's why it cannot cater all the requirements of all the industries. So that's why it is said that operating on one size fits all basis. So one size cannot fit to all the industry, like we can say. So this is the major disadvantage or problem or constraint with CTP. So because it is designed for we can say like one type of wastewater, but even the wastewater coming to the CTP is a diverse, is a mixture of multiple industries. So I so sometimes it may not cater the requirement of individual industry. Lack of access to capital investment. So sometimes capital investments may not be there to set up the CETP. Working capital, like if set up, the working requires some amount of money which is not there. Specialized technical skills, skill work, workman, skill workforce is not available, and inconsistent affluent quality from the member industry. So if an industry has collaborated with CETP, so they are not providing the required treatment so that the CETP may be affected. So this is the constraint with CETP. If four industries are supplying wastewater to CETP, but one industry is not able to provide the required effluent, means that industry is not able to treat their wastewater, uh, they are not able to give the primary treatment and they are directly discharging, so it may affect the CETP. Improper management of treatment units at common facility, varied nature and scale of industries, along with the addition of industries in haphazard manner without proper planning. No provision to tackle the fluctuations in pollution load and quantities at individual member industries. No separate treatment unit to deal with hazardous and toxic effluents. What are the different physical characteristics to be monitored at the influent CETP? What are the different physical characteristics to be monitored at the influent of CETP? So this is CETP plant. So what are the physical characteristics which we need to observe at the influent end? The influent end, what we have to see here, and the effluent end will be taken care by the regulatory body. So based on the influent and effluent characteristics, we have to treat the wastewater. Effluent, influent. So what is the gap? What is the that we have to treat? The difference in the influent characteristics and the effluent characteristics is the gap. That gap we have to treat. So physical characteristics are temperature. We need to see the temperature. How much is the temperature? Color. How is the color and order? And what are the total and volatile suspended solids? Total suspended solids and volatile suspended solids. These are the physical characteristics which need to be monitored at the influence of CETP. What are the different chemical characteristics to be monitored at the influence of CETP? So now we are talking about chemical characteristics. Chemical characteristics to be monitored. So these are pH, pH, carbonaceous substrates such as COD, POD, TOC, and toxic metals and compounds like heavy metals like we can say copper, chromium. So these need to be monitored. Why inlet effluent standards for CETP? Why inlet effluent standards for CETP? So in initial times, CETP were mere sinks of raw effluents from the industries. So these were just sinks of raw effluents from industries and suffered a lack of discipline in the pre-treatment at the industries. So initially the wastewater is directly discharged into the CETP facilities, and it made CETP upset, means inefficient. So that's why minimum amount of pre-treatment is suggested, so that to make the CETP work in an efficient way. So that's why some inlet effluent standards are uh, imposed. Pre-treatment standards. So effluent from industrial. This is the continuation of the previous question. Why inlet effluent standards are standards for CETP? So like we discussed, like initially there was no treatment. The wastewater from industry was directly discharged into the CETP facilities, which made the CETP upset or inefficient. So that's why some pre-treatment was suggested. So what are the pre-treatment standards? So these are here. So effluent from industrial processes require some form of pre-treatment prior to sending the effluents for further treatment at CETP. So this is mainly required when wastewater is carried through gravity lines, means sewers or some pipelines or open channel. So this is mainly required when wastewater is carried through gravity lines to minimize corrosion and clogging, and to prevent the reductions in biological treatment process efficiency due to toxic constituents. Pre-treatment standards for sulfides, sulfate, and pH are concerned while preventing corrosion of concrete parts in gravity pipes, and also the anaerobic condition leading to the formation of hydrogen sulfide, leading to the fire accidents. So that's why pre-treatment is required. Now we will study choice of technology. Why treatability studies are conducted? Treatability studies. So treatability studies are conducted to facilitate in characterizing the physical, chemical, and biological nature of the liquid waste streams of interest, and devise effective economical ways to treat and manage such wastewater to meet the regulatory criteria for safe disposal and reuse. And the studies are conducted to determine the specific treatment and recycling technologies, as well as to arrive at the capital and operational cost. What are the objectives of treatability studies? So the objective of treatability studies are convert converting the chemical composition of wastewater into environmental parameters to understand the nature of the effluent. Converting the chemical composition of wastewater into environmental parameters to understand the nature of the effluent. Conceptualizing the possible treatment schemes by conducting lab scale studies to support the hypothesis with respect to the conceptual treatment scheme, and also to arrive at operational parameters. Can a high BOD COD ratio wastewater treated biologically? Suppose if we have high BOD by COD ratio, can it be treated biologically? So we need to see what is COD and BOD. We have studied COD is biodegradable organic matter, plus non-biodegradable organic matter, and CO and BOD is only biodegradable organic matter. So if BOD by COD ratio is more, then we can say non-biodegradable organic matter is less. Is this part is less. So if BOD is more means biodegradable organic matter is more, so it can be treated biologically. Yes. What are the units used in preliminary treatment? So in preliminary treatment, the units and the what are the some treatment units are screen. They are used to separate floating materials, large floating materials, floating objects. And in preliminary treatment, we can use grit chambers. They are used for removing inorganic particles. It follows type 1 settling. Detention time is 1 to 2 minutes. And we can use communitors for grinding. Communitors for grinding the coarse solids. We can do pre-aeration for odor control. And we can do skimming. Skimming is for oil and grease removal. And most important thing is equalization. So we have studied about the equalization inline. There are two types of inline and offline. So these types of preliminary treatment are done uh, to preliminary treat the wastewater. Now we will talk about primary treatment. So what are the primary treatments? So primary treatment is to remove the settleable solids prior. So primary treatment is to remove the settleable solids. Remove the settleable solids. So it may include, it includes flash mixer, flocculator, and sedimentation. Uh, What are the secondary treatments? What are the secondary units used in the treatment plant? Secondary treatment is it is the purification of wastewater primarily with dissolved organic matter by microbial action. So what we are saying, purification of wastewater primarily with dissolved organic matter by microbial action. So organic matter is there and organic matter will interact with microorganisms, microbes, and because of the catabolism and anabolism, the microorganisms will gain energy and they will reproduce and they will remove the organic matter from wastewater. So this is the secondary treatment. So we can write it like purification of wastewater primarily dissolved organic matter by microbial action. So this is organic matter. This is microorganisms. What are the units used in tertiary treatment? We can say one more thing we can include it here. Like secondary treatment we were talking about. Secondary treatment. So based on the presence or absence of oxygen, they can be classified into aerobic and anaerobic treatment. Aerobic, aerobic process, anaerobic process. So if we talk about aerobic process, we can say like activity process, sequential batch reactor. This is aerobic process. Anaerobic process, like upflow anaerobic sludge blanket reactor, and like fluidized bed sludge blanket reactor are also there, and expanded bed sludge blanket reactor are also there. So likewise, we have different processes, and it can be categorized as also as based on the biofilm, whether the biofilm is attached or can be classified further whether the biofilm is suspended or attached. So it can be either attached loop system or it can be called as suspended loop system. So in attached loop system we have trickling filter, we have rotating biological contractor, and these are called RBCs, and we have activity stress process, we have membrane bioreactor, we have sequential batch reactor. Likewise, what are the units used in tertiary treatment? So in tertiary treatment, it includes physical and chemical treatment to meet the treatment objectives. It includes physical and chemical treatment to meet treatment objectives. Like here we can say we can provide membrane process, we can either provide adsorption, we can provide ion exchange, or we can provide disinfection. Likewise, we can provide a main membrane. We can provide different units of different types of membrane. Okay, so these are the tertiary units which can be used. What are the modes of disposal of treated effluents? So they are after uh, treating the wastewater from preliminary treatment to primary treatment, then secondary treatment, then tertiary treatment. And after we need to dispose the treated effluent. So how can we do? So the disposal modes of treated effluent from CETPs are they can be disposed either on the surface water bodies. They can be discharged either on the surface water bodies. The effluent can be discharged on land for irrigation, marine outfall, and it can be discharged on public sewers. But before discharging, we need to check the effluent characteristics. Before discharge, we need to check the effluent. We need to check the effluent characteristics of CETP, and we need to check the standards whether the characteristics whether those effluent characteristics of CETP are eligible to be discharged into the surface water body, on land for irrigation marine outfall, or public sewers. So then only we can discharge the treated effluent. What are some biological treatment methods? So we will study about some biological treatment methods. Like you can study about SBR. SBR is nothing but first study about ASP, active stress process. We will not talk about these processes in detail, but we'll just touch the topics. ASP. ASP is active stress process. So what happens? So in a tank, this is called aeration tank. Wastewater is supplied into the aeration tank, and it will interact. The organic matter will interact with microorganisms, and microorganism will metabolize and degrade and decompose organic matter into CO2 and H2O, and microorganisms will grow, and it will cause sludge to form, and the sludge is then transferred into the secondary sedimentation tank, and the effluent is taken out, and the settled sludge is recycled into the aeration tank to maintain proper F by M ratio. So the settled sludge in SST is called activated sludge. Called activated sludge. So basically in aeration we are providing oxygen or air to provide, because this is aerobic process, so microorganisms require oxygen as an electron acceptor. So microorganism will consume organic matter and convert it into CO2 and H2O, and that's why they grow. And these microorganisms, when they grow, they will increase in number, and that's why they are settled. They will be settling in SST, and from that SST it is again recycled by the numbers, and that settled sludge is then recycled into the aeration tank to maintain proper F by M ratio. This is the active sludge process. Now we'll understand about sequential batch reactor. So in this reactor, it is a batch reactor. So all the things which are happening in the active sludge process ASP will happen in the one tank itself. All processes in one tank, like what is happening. First we are filling, then reaction, reaction is going on. After reaction, it is settling. Will react, settle, and decant. So these are also called fill and draw type tanks. So in one tank itself, we are filling it, we are allowing it to react, settle, and decant. So the advantage is that SST not required. Pumping of returned activated sludge not required. These are the advantages. Then we can understand about rotating biological conductor RBC. So what happens? It is an attached rope system. So previous two system which we studied were suspended rope system. So in RBC rotating biological conductor, so the discs are provided to attach the layer of biomass over them. These are the discs. This is the rotating shaft. Rotating shaft. So these discs will be 40% submerged. 40% submerged. And the biomass will grow over the film. Biomass or biofilm grows over the rotating disc, and that biomass interacts with the organic matter in the wastewater and oxidizes the organic matter and uh, and in that process wastewater is getting treated. So influent here, affluent, like this. Likewise we can have trickling filter. In trickling filter, water trickles over the filter. This is the influent. This is rotating arm. The water will come out of the nozzles. And these are the filter media. So as the wastewater comes out of these nozzles, the wastewater will interact with the filter media, and it will cause the slime layer to form over the filter media, and media uh, that media will acquire the biofilm over its surface, and that when interacts with the incoming wastewater oxidizes the wastewater, and in that way the wastewater is getting treated, or the organic matter is getting removed. So in RBC also the SST is used. SST is used after RBC because the wastewater, because the biomass uh, will cause suspended solids. The biomass which when the biomass or biofilm which is in the disk will be removed, and it will cause suspended solids to form. So that's why it needs to be removed in SST. So and I will write it here like this. Uh, when it is removed, it will be in suspension. That's why SST secondary sedimentation tank is needed. In the same way, in the trickling filter itself, it's an attached dose system. The influent and the effluent will be collected here somewhere. The removal of this, suppose this is the media, initially aerobic layer. When biofilm will grow, then it will be anaerobic and aerobic. Anaerobic layer. No oxygen. And this will be aerobic. So because of no food and no oxygen, they will go into the death phase, and that's why the bond between this media and the biofilm starts to lose, and that's why the biofilm will detach from the media. That is called sloughing. Biofilm detaches from the media, called sloughing. So because of this thing, SST is required in trickling filter. And one more thing, effluent is recycled. Effluent is recycled in trickling filter, not sludge. Effluent is recycled to increase the rate of sloughing. Because what we want this layer to form early. We want this layer to form early, and to leave the home early and detach early. So that's why our treatment will be fast. So this was about the last lecture. Thank you.